Okay, guys, had a slight problem, so we're going to start over. This is 7-6 function operations. Um, we are going to be dividing, subtracting, multiplying, and dividing functions on this first part, and then we'll do the composite of two functions on the second part. Um, Looking at your function operation definition box, f plus g of x is the same as f of x plus g of x, and the rest of it flows um, with what you would think would happen as well. So let's go ahead and put this to the test. Okay, so let f of x equal negative 2x plus 6 and g of x equal 5x minus 7. Find f plus g, which is the same as f of x plus g of x, so this plus that, and f minus g, negative 2x plus 6 minus 5x minus 7, and their domains. Okay, so f plus g is equal to negative 2x plus 6 plus 5x minus 7. Adding like terms, we have negative 2x plus 5x, so that's going to give us, 3x, and these are done. 6 minus 7 is minus 1. Okay, and the domain is going to be asking what values of x would work in this particular equation, in this particular function. And in this case, there is never a time when a value of x would make this function not possible. So therefore, undefined. This one is going to be the domain. I'm going to do it with the D with two lines here. Domain is all real. Okay. F minus g is the same as negative 2x plus 6. And then minus, and I'm putting this in parentheses so that I don't forget to distribute this minus. Okay, we got to distribute it here, and we also have to distribute it here. So this is the same as negative 2x plus 6 minus 5x plus 7. Combining these like terms, we have negative 2x minus 5x, so that's going to be negative 7x. 6 plus 7 is 13. So we have negative 7x plus 13 is your new function. The domain, again, there's no place where any value of x would make this an undefined function, so your domain is all real. Okay? A time when you would have a domain where there should be a limit would be with an example that would be 1 over 2 plus x. You cannot have a denominator equal to 0. So again, this is just an example. So 2 plus x cannot equal 0. So subtract 2. So you would have x cannot equal negative 2. It would be all real except x is 2. Pretty cool, huh? All right. Oh, sorry. Next example, multiplying and dividing functions. So looking at, these functions, we have f of x is x squared plus 1, and g of x is x to the 4th minus 1. We want to find f times g, which would be x squared plus 1 in parentheses times g is x to the 4th minus 1. Okay, now we need to distribute, so we're going to FOIL. So we have x squared times x to the fourth, which keep the base, add your powers. So we have x to the sixth. Outside, x squared times negative 1, so negative x squared. Inside, 1 times x to the fourth, so it's x to the fourth. And then the last 1 times negative 1 is negative 1. Putting these in order from greatest degree to least, 6 to 4, so that would be 6, 4, 2. So x to the sixth plus, because it's a plus x to the fourth, minus x squared, and then minus 1. And in this case, there's nothing in the denominator. There's no place where the domain would not, any value of x would make this a undefined function, undefined equation, so the domain is going to be all real. Doing f divided by g, we get x squared plus 1 over x to the fourth minus 1. Okay, now this bottom is a difference of squares. X to the fourth is the same as x squared times x squared minus 1. Excuse me, is the same as negative 1 times positive 1. So we're going to rewrite this. X squared plus 1 over x squared minus 1, x squared plus 1. Very cool, huh? This cancels out with this, leaving 1 up here. So this gives us 1 over x squared minus 1. Now, we do have a limitation because we cannot have this denominator equal to 0. So x squared minus 1 is 0. Add 1. X squared is 1, so x is plus or minus 1. Right? So your domain is all real except x equal to plus or minus 1. So this would be your answer, and this would be your limit, your limitation, your domain. Okay, that's it for questions or examples 1 and 2. Excuse me. Hope it made sense. Hope you understand. If not, you know what to do.